Hello friends, Prerna this side from iNeuron. Welcome back to all of you. So we have completed sequence and series, 4 exercises of sequence and series. We have done all type of question that can come from this chapter, and now we will discuss miscellaneous exercise on chapter 9, in which we are going to discuss each and every type of formula, every type of question that can come from the chapter sequence and series. Okay, so let's start from question number 1. So the question says, show that the sum of m plus nth and m minus nth term of an AP is equal to twice the mth term. So we have to show that sum of mth, m plus nth and m minus nth term of an AP is equal to twice the mth term. We need to prove this. Okay. So let's start. First of all, we will find left hand side. Value of left hand side. So m plus nth plus m minus nth. So it is a plus n minus 1 d. So here n is actually m plus n. Okay, so it is a plus n minus 1 d. Similarly, for this part we have a plus m minus n minus 1 d. So now we can open the bracket. So it is a plus md plus nd minus d plus a plus md minus nd minus d. Okay. Now we can cancel out nd with minus nd. So we have 2a plus 2 times md minus 2d. Or I can say that if I'll take common 2, it is a plus md minus d. Okay, so it is 2 a plus, if I'll take common d, so it is m minus 1. Sorry, m minus 1, isn't it? So we have 2 a plus m minus 1 d. Now this can be written as mth term. What should be the mth term? Mth term will be a plus m minus 1 d. That's it. So this is right hand side which we need to prove. Hence proved. So this was question number 1 of miscellaneous exercise. Okay. This question was from AP. From AP. Okay. Okay, so let's move on to next question. Question number 2. Question number 2 says, if the sum of 3 numbers in AP is 24 and their product is 440, find the numbers. We know that when the question says that sum of 3, product of 3, in case of AP, we need to consider 3 terms, if you remember. So we will discuss, let the numbers be a minus d, a and a plus d. A minus d, a plus d. Sum of the 3 number in AP is 24. So first hint is sum of these 3 terms is 24. So we can say it should be minus, it should be minus. Okay. Now this is a minus d plus a plus d is equal to 24. Now it will give 3a is equal to 24. So a is equal to 8. Okay. So the question says their product is 440. So second thing is product of these 3 things is 440. So it is a minus d into a plus d, and their product is 440. Now what is the value of a here? 8. So we can say 8 minus d, 8 plus d, and then we have a 8, and it is 440. So it is 8 square minus d square, and here we have 440 by 8. 64 minus d square is equal to 55. So 64 minus 55 is equal to d square. Okay, so d square is equal to D is equal to 3 or minus 3. So I am taking 3 here. So what are the three numbers that we have assumed? We have assumed a minus d, a and a plus d. So a minus d, then a plus d. Okay, so it is 8 minus 3 and then 8 and then 8 plus 3. 5, 8, 11. Now if I will take the value of d as minus 3, then it will give the different set of numbers. Okay. Okay. So this is the question number 2. Now moving on to question number 3. Again this is a question of AP. The question says let the sum of n, 2n, 3n terms of an AP be S1, S2 and S3 respectively. Show that S3 is equal to 3 S2 minus S1. So it is actually 3 at the subscript. So we have to show that S3 is equal to 3 S2 minus S1. Okay, this is the question that we need to prove. And the question says sum of n terms is S1, sum of 2n terms is S2 and sum of 3n terms is S3. That's it. So this is the complete data given in the question and we have to proceed further. See what it says. It says n by 2, 2a plus n minus 1d is equal to S1. Okay. Now what it says? This says 2n by 2, 2a plus 2n minus 1d, and again it is S2. Okay. Now the third thing is 3n by 2, 2a plus 3n minus 1d, and it will give S3, and this is equation 3. So this is the data given in the question. Okay, now what need to prove? We need to prove this. So we should solve this part to get this part. So what I am doing here, I am writing the RHS part and putting the values. So it is 3 S2 minus S1. Okay, so it is 3 S2. What is S2? S2 is 2n by 2. 2n by 2. S2 is 2n by 2. And then we have 2a plus 2n minus 1, 2n minus 1d minus S1. S1 is n by 2, 2a plus n minus 1d. Okay. Now 3. Okay. Now see, we can take n by 2 common. So what we have now? I have taken n by 2. So we have 2 into 2a plus 2nd minus d minus. Again I have taken n by 2. Okay. So what we have? 2a plus nd minus d. That's it. So it is 3n by 2, 4a plus 4nd minus 2d minus 2a minus nd plus d. Now on solving, it will give 3n by 2, 4a minus 2a is nothing but 2a. Okay, then we have 4n minus n, 4n minus n. So if I'll take d common, I have 3n minus 2d plus d minus 1. Now it is, if I'll place the value of n as 3n, this is the third S3. 3n by 2, 2a plus 3n minus 1d. So we can write it S3. Isn't it? That's it. Easy. Okay, you just need to put the values and you will get the S3, that is LHS. Hence proved. That is LHS. Hence proved. Okay. Okay. Moving on to next question. Next question is question number 4. Question number 4 says find the sum of all numbers between 200 and 400. When it says between, then you cannot take 200 and 400. You have to take numbers between them which are divisible by 7. So first of all we have to think that after 200 which is the first number which is divisible by 7. So if you can calculate, that's okay, or if you can't do it, then you can do one thing, take a number after it, after 200. So it is let us suppose it is 201, and let us check that what is the remainder. See, here it is 5. Okay, here it is 5. So if I'll subtract 5, then it will come something, sorry, from this one, then it will come something less than 200. That we don't want. So what we have to do, we have to consider a number. Let us suppose I am considering 207. Okay, let's see what it gives. So we have 4. So if I'll subtract 200, 4 from 207, it is 203. Isn't it? So this is the first number. So I am writing it 203 and then add 7, since we have to check it is divisible by 7 or not. So it is 210, 217, and it goes on like this. Now 400, if I'll check on 400, it is actually 400 by 400. So we have 399. You can check it. You want to check it, you can check it. Isn't it? So this is the way you can check. So we have the AP, okay? We have the AP. Now we need to find the sum. So what we have to do? We have to find the sum. So we have to memorize the formula for sum of n terms in an AP. So what it gives? See, we have Sn is equal to n by 2 a plus L. Sn is equal to n by 2 a plus L. So do we know the value of n? No, we don't. So we have to find the value of n. You can use this formula or 2a plus n minus 1, that one also. So an is nothing but 399, and according to the rule 203 plus n minus 1 d is equal to 399. So n minus 1 7 is equal to 399 minus 203. So it is 196. Okay, so it is n minus 1 is equal to so n is nothing but 29. N is nothing but 29. So we can use it. So it is 29 by 2. A is 203 plus L is 399. Okay, use it and solve it. So this is 29 into 301. Just multiply it, it will give you the answer. So this was quite easy. The question is you have to find the sum of all number between 200 and 400. So we have calculated and we have created the AP. Now what you have to do? You have to find sum. So I have written the formula for sum. So we know the value of A, we know the value of L, but we don't know the value of N. So for that I have used the formula of AN. Got it? So this is the question number 4 of miscellaneous exercise. Okay. So moving on to next question. Next question is find the sum of integers from 1 to 100 that are divisible by 2 or 5. Okay, not 2 and 5. So number which are divisible by 2. divisible by 5 and divisible by 10. Why I have written divisible by 10? Since the question says that you have to find the sum of integer from 1 to 100 that are divisible by 2 or 5. Either it should be divisible by 2 or divisible by 5, but not divisible by 10. And is not there. And is not there. So you have to take the numbers which are divisible by 2, by 5, and then you have to subtract the number which are divisible by 10. Okay, so what are the number which are divisible by 2? So we have to write the table for 2. For 5 we have to write, okay, and for 10 we have to write. Okay, now what you have to do? Sum of integers divisible by 2. So for this AP you have to find sum. Okay, so it is, how many terms are there in this AP? If you know, if you can calculate, then okay. If you don't want to calculate, then use the formula for confirmation. So you can say that last term will be 98, isn't it? So it is 98 is equal to 2 plus n minus 1 d. So it is 98 minus 2, 96 equal to n minus 1, 2. So n is equal to 49 here. Okay. So question number 5. Question number 5 says find the sum of integers from 1 to 100 that are divisible by 2 or 5. Since the question says that you have to find the sum of integer from 1 to 100, which means you can take 100. Not between 1 and 100, from 1 to 100. So first of all, we will write all the numbers which are divisible by 2. Numbers or integers divisible by 2. Okay, numbers or integers divisible by 2. So I am writing integers divisible by 2. So it will be 2, 4, 6 and then till 100. Similarly, you have to write integers divisible by 5. So for that, what are the numbers? 5 till 100. But the question says that you have to find the sum of integer from 1 to 100 that are divisible by 2 or 5, not and. Okay, so it says 2 or 5. So you have to remove all the numbers which are divisible by both. Okay, so I am writing those numbers also. So integers divisible by both 2 and 5. So it will be 10, 20, 30 till 100. Now see, the question says that you have to find the sum. So you have to find the sum of integer from 1 to 100 that are divisible by 2 or 5. So first of all, I have to find the sum of all the integer which are divisible by 2, then sum of all the integer which are divisible by 5, and then I have to subtract the integer which are divisible by both, since the question says that I have to find the sum of integers which are divisible by 2 or 5. So for finding sum, first of all, we should know the number of terms. Do we know the number of terms in this part, and in this part? No. So first of all, we have to find the n. See, 100 is equal to, since the last term is 100, 100 is equal to a plus n minus 1 d. What is d here? 2. Now 100 minus 2 is 98 is equal to n minus 1, 2. So 98 by 2 is equal to n minus 1. So it is n minus 1. So it will give the value of n, that is 50. Now we can find the number of sum of integers which are divisible by 2. So sum of integers divisible by 2. So what it should be? It should be n by 2, 2a, 2 into 2, 4 plus n minus 1, 50 minus 1, 49 d. Now I can take common 2, so it is 50 by 2 into 2, and here we have 2 plus 49. So it is 50 into 51. Okay, it is 2550. Okay, so this is the first part. We have calculated the sum of integers divisible by 2. Okay, and then we have to find integers divisible by 5. So again we will do the same thing in the same pattern. First of all, we have to find the number of term to find the sum. So 100 is equal to a plus n minus 1 d, isn't it? So it is 100 minus 5, 95 is equal to n minus 1, 5. So it is n minus 1. So n is nothing but 20. Now we have the value of n. So we can find the sum of the integers divisible by 10. So I am finding it here. Sn is equal to, you can write sum of integer divisible by 5, n by 2, n by 2. Then we have 2a, 2 into 5 plus n minus 1, that is 19, and d. So we have 10, 95 plus 10. So it is 105 into 10. So it is 1050. Okay. So this is the second part. Now what we have to find? We have to find integers divisible by both. Again we have to find the value of n. So nth term is equal to a plus n minus 1 d. 100 minus 10 is 90. 90 is equal to n minus 1 d. Okay. So n minus 1 is equal to 9. So n is equal to 10. N is equal to 10. So we can find the sum. Now the sum will be Sn is equal to 10 by 2, 2a. 2a, that is 2 into 10. 20 plus n minus 1. 10 minus 1, 9 into d. d is 10. So this is 10 by 2, and here it is 90 plus 20. Like this. Okay, so it is 110 into 5, so it is 550. Now required sum is 2550 plus 1050 and subtract 550, I'm sorry, 550. Okay, 2550 plus 1050, and you have to subtract all the numbers which are divisible by both. So what it will give? It will give 3050. And this is the answer of question number 5. Got it? This is the answer of question number 5. Okay? Okay, so moving on to next question. Question number 6. Question number 6 says, find the sum of all two-digit number which when divided by 4 yields 1 as a remainder. Yields 1 as remainder. So you have to find all two-digit number which when divided by 4 yields 1 as remainder. Which means you have to take a number which is multiple of 4 plus 1. So that it can leave remainder 1, isn't it? So the first two-digit number which is divisible by 4 is 16. So I am taking 17. You can see that remainder is 1. That's why I have taken 17. So this is 17. Okay. Now, next is it should be first number will be, I think, 13. No. Like this. Okay, now what should be the last number which is divided by 4? So if I'll take a 96, I think 96 is the last 2-digit number which is divisible by 4. Like I said, so we have to take 97. So this is the sequence. Find the sum of all 2-digit number which when divided by 4 yields 1 as remainder. So if I'll divide it by 4, it will give 1 as remainder. Again this will. So it is 4 2s are 12 plus 1. Okay. 4 3s are 12. I'm sorry. So this is the sequence. Now you have to find the sum. What is A here? A is 3. What is D here? Okay, and here nth term is 97. So we can find the value of n. So an is equal to a plus n minus 1d. It is an AP, isn't it? It is an AP since the common difference is same. So 97 is equal to 3 plus n minus 1, 4. So we have 97 minus 3, 94 equal to n minus 1 divided by 4. One second. Oh, sorry, there is 13. Okay. Sorry, there is a small error. So it is 84. 84 by 4 is equal to n minus 1. Okay. So n is equal to 22. N is equal to 22. Got it? Okay, so we have the value of n here. You have to find the sum. So Sn is equal to n by 2 2a plus n minus 1, that is 21, and d. What is d here? 4. Now I can take common 2 from both these groups. So it is 22 by 2 and I have taken 2 common. Then I have 13 plus 21 into 2. 21 into 2. So it is 42. So we have 22 into okay. So it is 55 into 22. 1210. Okay, so it is 1210. This is the answer. Got it? So this is question number 6. Okay, moving on to next question, that is question number 7. This question is quite different. The question says if f is a function satisfying fx plus y is equal to fx into fx plus y is equal to fx into fy. For all xy belongs to natural number, f1 is given, f1 is 3, and let us write what are the given things. f1 is 3, okay, and summation x equal to 1 to n fx is equal to 120. So this is the complete data that is given in your question. Got it? That is given in your question. Now we have to discuss that what should be the value of n. So you need to find the value of n here. Okay, so since we have fx plus y is equal to fx into fy, let us suppose that I am writing x as 1 and y is 1. Let us suppose. So this will give f of 1 plus 1 equal to f of 1 into f of 1. So it is nothing but f2. f1 is 3 and again 3 it is. So it is 9. It is 9, isn't it? Now if I want to find f3, so I can write f1 plus 2. So it should be f1. In place of x I am writing 1 and in place of y I am writing 2. So f1 is 3 and f2 is 9. So it is 27. Clear? Now if I want to find F4, so I can write F1 plus 3. You can write it in any manner. So we have F1, F3. What is F1 here? 3. And what is F3 here? What is F3 here? This is the F3, no? This is the F3. This is F2. This is F3. Now I am finding F4. So what is F4? F4 is F1 into F3. F1 is 3 and F3 is 27. So it is 81. Okay. So we have F1, here F2, F3 and then we have F4. Okay. So now we have the AP. 3, 9, 27, 81, AP. No, it is not an AP. It is a GP, isn't it? 3, 9, 27, 81. So it is a GP. Okay. Now what we have? We have summation x equal to 1 to n, fx is equal to 120. Okay. So what we can do? We can write 120. 120 is equal to, so this is a GP, isn't it? This is a GP. So we can write down the sum of GP. So it is A Rn minus 1 by R minus 1. Can we write it like this? Yes, we can write it like this. So what it will give? It will give 120 into 2 by 3 is equal to 3 to the power n minus 1. So it is 3 to the power n minus 1 is equal to 80. 3 to the power n is equal to 81. 3 to the power n is equal to 3 to the power 4. So n is equal to 4 by the law of exponents. Clear? Clear to all of you? Very easy it was. Okay, so let's move on to next question, that is question number 8. I hope it is clear to all of you. This question was quite different. You have to go through different methods in some of the questions. So now the question comes from GP. The question says the sum terms of GP is 315, whose first term, okay, we have Sn. I don't know how many terms are there. So we have Sn. First term and common ratio. A is 5 and common ratio is 2 respectively. Find the last term and the number of term. You have to find n and nth term. That's it. Okay, so we can apply the formula of Sn only since we have the value of Sn only. So write it down. Sn and here R is 2. So you know which formula I am going to opt. So Sn is equal to A Rn minus 1 by R minus 1, isn't it? Isn't it? Okay, so what is Sn here? Sn is 315 equal to A 2 to the power n minus 1 by 2 minus 1. Okay, so it is 63 is equal to 2 to the power n minus 1. It will go on that side, so it is 2 to the power n equal to 63 plus 1, 64. So it is, one second. So it is 2 to the power n and it is 2 to the power 6. So n is equal to 6. N is equal to 6. Okay. Now you have to find the value of an. So an is nothing but a plus n minus 1d. What is, oh sorry, it's a GP. I'm sorry. So nth term is a r n minus 1. What is a here? 5. What is r here? 2. What is n? N is 6. So it is 5 into 2 to the power 5, or you can say 5 into 32. This is the answer. Okay. So this is the answer of question number 8. Quite easy. Okay. Moving on to next question. The question says the first term of a GP is 1. So the question says that first term is 1. Sum of third term and fifth term. Third term and fifth term is 90. Find the common ratio of GP. This is the data given in the question number 9. So in question number 9 we have A, we have sum of third and fifth term, and then we have to, okay, so what is third term? Third term is AR3 minus 1 plus AR5 minus 1 is equal to 90. If I'll take A common and R also, R square, so it is 1 plus R square. We know that value of A is 1, so 1 into R square only, and here it is R square plus 1 equal to 90. Okay, let's suppose I am assuming R square as x. So it is x into x plus 1 is equal to 90. So it is x square plus x is equal to 90, or we can say x square plus x minus 90. So on factorizing, 10 and 9, so it is 10x minus 9x minus 90. It will give x plus 10 minus 9 x plus 10. So it is x minus 9 x plus 10. So it is nothing but 9. Okay, so we can say that x is 9, which means r square is 9, or we can say r is equal to 3 or minus 3. Okay, so you can say r is 3 or minus 3. So this is the answer of question number 9, isn't it? Very easy this was, isn't it? So this is question number 9. Okay, so moving on to a next question, that is question number 10. Question number 10 says the sum of three terms in a GP is 56, and if we subtract 1, 7, 21 from these numbers in that order, we obtain an arithmetic progression. Find the numbers. Okay, so the question says that sum of three numbers in GP is 56. Okay, so if I say AR and AR square is 56, and if we subtract 1, 7, 21 from these number, so if I'll subtract 1, 7 and 21, then they are in AP. So this is rough idea of this question. Now see, if the question says that you have to pick three numbers, your numbers are in GP and there are only three numbers, then what we have to assume? We have to assume A by R, A and AR, isn't it? So first of all, we'll start from here. Let the numbers are this. Okay, now the question says their sum is, so I am taking A common, then we have 1 by R plus 1 plus R is equal to 56. Okay, this is first equation. Now it says if we subtract 1, 7 and 21, so I am subtracting 1, okay, and then I am subtracting 7, and then I am subtracting 21. Now it says that these are in AP. If they are in AP, then second minus first is equal to third minus second. Okay, since they form an AP, okay, since they form an AP, we can say, see, if three numbers are in AP, A, B, C are in AP, then we can say B minus A equal to C minus B, or simply we can say 2B is equal to A plus C. In the same manner, we can write twice of second term. Twice of second term is equal to first plus third. Okay, first plus third. So it is 2A minus 14 is equal to A by R minus 1 plus AR minus 21. Okay, so I am bringing all the variable one side. So it is 2A minus A by R minus AR is equal to 14 minus 22. Okay, 14 minus 22. So it is, so if I'll take a common, it is 2 minus 1 by r minus r. And here we have minus 7. Okay, minus 7. Now this is equation number 2. Now if I'll divide both the equation 1 and 2, then we can see that we can cancel out the a part. So I'm writing it in that manner only. So a 2 minus 1 by r minus r by a 1 by r plus 1 plus r is equal to minus 7 by 56. Okay, cancel out. Okay, we will proceed further. I want to solve this question in this sheet only. So let's proceed from that side. So it is 2r minus 1 minus r square. And at the denominator we have 1 plus r square, and it is minus 1 by 8. 7 8s are 56. Now on cross multiplying it is 16r minus 8 minus 8r square equal to minus 1 minus r square. Now bring everything on that side. So 8r square, this side it will 8r square minus r square. Then we have minus r minus 16r. Then we have minus 1 plus 8 is equal to 0. So it is 7r square minus 17r plus 7 is equal to 0. Okay, is equal to 0.